Thanks. So this works. Yesterday we presented that proof of concept on the side of employment, right? Today's proof of concept, there are actually three sub proof of concepts on the side of the smart mobility. Okay, just few introductory slides. Later we have like 3 live demos, right? So I'll try to squeeze this in this few minutes. We all know mobility is relevant, so no need to explain this, right? So in our proof of concept, we used, historical and real-time data sets, so the old data sets and the data which is actually coming directly from the wire, which you will see. Then next stage was really aligning these sources, right? This is very important so that we get some synergies along so synergies in terms of interoperability, construction of models out of this data, right? So this could be either causal, correlation, prediction, and for statisticians this is important somehow to extract the statistical indicators which have some meaning, and of course to have also a system which actually works, right? Now a couple of policy questions which are related to this. I think this was touched already in many ways today. So this goes everything from clean, sustainable mobility, journey planning, local infrastructure, then relating to physical activity, which we just heard, right? Safe and secure transportation and efficient transportation. So this would be like policy-related questions, which most of these presentations today are touching, right? Now, again, still one of the last slides. We have stakeholders and data holders, and somehow we need to bring this two sides together. So stakeholders would be everybody from statisticians over citizens up to the academics, right, which we also just heard, right? And on the other side, we have data holders, which would be obviously traffic management, maintenance companies, over mobile data holders up to social media. Now having on one side all these data streams, right, from the bottom and connecting them to all these stakeholders, somehow this seems like a landscape of what we want to achieve, right, with this. We mentioned already what kind of data sources we have. Here is just a little bit more detail. So we have historical and current traffic data. So let's say in this case, this would be loop sensors in Slovenia. This is over 200 gigabytes. It's not really big data, right? So it's something which you can put on a memory key at the end, but still kind of reasonable, right? Mobile app sensors, you will see later live demo how we can use mobile app sensors to model persona, right? Weather provides the context, right? Affects the mobility and traffic. And mobile operated data in this presentation, which we are not using, although it was part of the scenario, right? So basically we have 3 proof of concept scenario. First one is, so we wanted to add something a little bit, let's say, I wouldn't say less usual, but a little bit outside the usual counting thing. So the first one is sensor causality, right? So we have plenty of sensors. Today we talk about sensors in most of the presentations. Now, one thing is, okay, to establish infrastructure, nice, we collect this data, we store the data, but now the modeling really adds the value, right, to the whole thing. And while this causality, some form of causality, right, would reflect also dynamical aspects of traffic, and out of this we can derive many indicators which are of some relevance. The second scenario, it's about virtual sensors, right? We all know sensors is something which you install and works and you need to maintain and so on, but sometimes we need sensors somewhere which is either hard or expensive to install, or we need it just temporary and so on. This is what we call virtual sensors. Yeah? Virtual sensor is just something which you actually doesn't exist in reality, but acts like a sensor, and it's calculated out of the physical sensors, right? And often works just equally well as the real one. Yeah? And the third scenario is about mobility personas. Okay, let's go now through all three. Okay, this is architecture of the system, which, again, we won't go too much into details. We have data sources, these three proof of concepts, and target users, and so on. Okay, let's go to the first one. So, sensor causality. So, let's say I'll show you an example of real sensors, right? So this is Slovenia, kind of not too big, not too small country, right? And just right. So these are sensors on the major highways, right? So there are more sensors, but these are the ones which basically are, I would say, the key, right? Now, you see many sensors, and these sensors sometimes actually, they are connected, right? So if you get flow of traffic through some roads along, I don't know, up here, obviously these sensors are connected in one or the other way, right? They need to be, because it's like traffic is pretty much like a flow of water, right? If you push the water here, eventually it will go there, and sensors on the other side will also get pretty much the same flow, not necessarily the same one, right? And as part of, apart from this, okay, this short demo, so we cannot show the causality is really a model, right? A model which can be used for other things like prediction and so on. So here, what you see based on this model, you can see predictions of so the real speed, and so the light blue is the predicted speed, right? And the dark one is the real speed, right? You see that the light blue actually follows pretty much the real speeds, which means that our prediction model actually works pretty well. Later I will change a few parameters, right? Traffic flow, so this is the speed, right, which we detect and predict, right? Straight out of the data from these sensors. The second important indicator is traffic flow, so the number of cars, right? And the third one is just the congestions and these kind of things, right? Now I will just so this is like default. Now I will do prediction horizon, right? So I will say, okay, let's predict for something like, how many, 18 hours ahead, right? So you see the real data is still the black thing, but the last part is missing. It's only predictions, right? And so this is pretty much, it behaves as predicted, right? So the deliverable reports the exact figures, right? So this is one way how we can play. So once we collect all the data, build a model, then we can play with these kind of prediction scenarios on the top of real data. Okay, this is just a quick demo. Later we'll come back to a couple of others, right? Okay, let's go back now to the presentation for a couple of slides. Okay, the next scenario are virtual sensors, right? Maybe it's just relevant to say, out of this model, which I was just showing, we can pretty much derive this set of statistical outputs, statistically relevant outputs for, well, understanding what's happening. So these are just parameterized indicators, pretty much what you see here. So I won't go through them. Virtual sensors, right? So virtual sensor, as mentioned before, right, is something where you see the picture on the right. So we have like 4 real physical sensors which are installed. Probably somebody spent quite some money to install them and so on. But we would like to have a sensor here, right, in the middle, which would provide us with some value for whatever reason, and maybe we are not really too happy to now to dig into the road, right? Make the whole infrastructure, stop the traffic for, I don't know, half a day and so on. And but we can calculate actually the value of these sensors, of this one particular virtual sensor, from the nearby sensors or from the sensors which actually relate to it, right? This means like sensors plus the context usually we would use as well, like weather and other conditions which possibly influence the value, right? So so as part of this proof of concept, we made well, piece of research, and we have results with them on when and how to calculate or construct this kind of virtual sensors for the area of Slovenia, right? Now, as you can imagine, so here's a real example, right? An area here, right? So this is area close to Trieste, and which is pretty dense and highly predictable, right? So here in this area, this is pretty easy, and we can build this virtual sensor easily and very reliably. While, let's say, if we have an area which is not really populated, actually these are Alps, here, let's say, if you try to construct a virtual sensor, it wouldn't work well. So one of the messages or lessons learned would be that you need to be careful. So it's not always virtual sensors are possible in many areas of, let's say, of the landscape are just possible and work perfectly well, while some other areas maybe need some more context so that you would build them. So not maybe just straight from the sensors, but you would need some extra data. So this is a little bit more explained in the deliverable. So here, the point is to mention that this concept exists, and that this was part of results. Now the third proof of concept scenario is mobility personas, right? Mobility personas are, were mentioned already in a couple of presentations today. So we would like to model the flow, or model either personality, one individual person, or groups of, let's say, entities or people, and detect their mobility patterns, right? Now, as part of this deliverable, again, we had few approaches how to deal with this, but let me just show the live demos, right? Okay, so first I will show these mobility patterns, and from this will be like picture from Ljubljana, from Slovenian capital right now, right? So here you see all the city buses. Actually, if you will spot carefully, they're actually moving, right? Just let's wait a bit. They will start moving. So this is real-time tracking, right? Did they move? Yeah, they did. Yeah. So these are city buses, right? And here on the left side, each bus has its own ID, right? And if we press one random bus, right, this one, so we would see the complete path for, I guess, today, right? February, yeah. Or no, probably, yeah, this is for today, right? And the last days, right? So we see exactly where it was moving and so on, right? And then we can go to particular data points and so on. But more interestingly, right? So here we can see how a group of entities actually move, and we can model the whole group of entities, right? Maybe more interesting would be the follow demo, which is actually from one of our guys, which was one of the major contributor to this software as well, Luka Bradeško, right? And he, for last couple of years, he's recording himself, right? So we have complete data where he traveled, where he sleeps, drinks, eats, and so on. Right? Works. So in the last year, he's in New York on postdoc, and so we'll put the dates now from early 2018 till pretty much today, right? So you see this is Manhattan, right? And okay, we can zoom in. Okay, so we see major points where he actually is moving. So bigger the point, more often the person was there. So we see that there are like two major groups of points, like here and here, right? So he works here and he lives here, right? Here, unclear, to be honest, maybe mistress, I don't know, something relevant. But let's investigate this, right? That's why we have personas, right? And that's why it's the software. Right? For boring deterministic scenario, nobody needs this. Okay, so let's say we can zoom in here. So we can check this point. It says actually this is this address. Actually, I wrongly clicked. So this is Bloomberg Tower. So he's in postdoc in Bloomberg, and we see exactly. This is description of location, how many visits was there. Typically, he stays like for 5 hours and a half there per day. Yeah. Typically, he would be. This is frequency of visits per hour of the day, right? So you see that he comes sometime in the morning, right, and he stays a little bit later in the evening, right? So this is his profile of being in that particular location, right? And he's mostly there on the working days, while over the weekend he's usually more like at home, right? And which hours on location by day, so it's fairly stable, right? So here you have metrics, days per hours, right? Okay. Now going on this other location, right, where he lives. I think this is this one. So here, why there are so many circles? Because sometimes this GPS has hard time locating exact. So it's very dense area, and sometimes assigns the location to a wrong entity, right? I think it's this one, yeah. So this is his place where he lives. So here you see now that he is frequently at home, right? Okay. He is more or less consistently here, while the hours, right, would be so over the weekend he would be a little bit more at home as compared to the rest of the week, right? Which is like complementary to his business, right? And this is the more detailed metrics, right? Now we can also check a little bit of his behavior, right? Since we talk about personas, we can say, okay, show me predictions. So if Luca is on that particular location, right? Or maybe we can check for the place where he works first. So this is this Bloomberg building, right? Yeah. Now we say show predictions on the map. Okay. We see now. Okay, if Luca is here, right? Then we have 8% chance that he goes to this mysterious place, right? 10% chance that he goes to this place, which is we couldn't, or the software couldn't associate GPS location with some known entity. So we use Foursquare as, to match the GPSs, and sometimes it's just not there, and then you cannot say much. And so 10% here, 8% here, and the rest he typically, after Bloomberg, he goes home, right? So this is there's 17%, 19%. Okay, we can zoom in. Yeah, so he would go pretty much to his home, right? So this is pattern after this, right? Now we can check also. Okay, what's this mysterious location? If he's here, what he does afterwards, right? Again, we can analyze details, but maybe it's not decent. Let's see the prediction. So mostly he goes home afterwards, right? Occasionally, in 6% of chances, he goes also to Bloomberg to work, right? So this would be one way of seeing this, right? Now, if we zoom out, right, the whole world, right? He appeared also in Slovenia in the meantime, right? So we would see, yeah. Conclusions, yeah. So conclusion is just that I wanted to show that he actually moves also here, right? Anyway, boring detail, right? So he lives here, he works at JSI and so on, right? So here we would see his patterns on that side. In the meantime, here in the middle, you can see exactly how he's moving these days, right? Where he walked, where he drove, and when he was at whatever place. So this is associated with a mobile app, so that everything works. So this is just the web interface. Okay, just going back to slides. Basically, we touched most of the issues. Here we have a little bit more statistical analysis also on how these profiles could be, or personas could be calculated, but it's pretty much derived from what you saw now in the live demo. Quality assurance, you're all aware that we deal with plenty of imperfect data, and also models cannot be perfect, but if you join them properly, then actually you can get a useful result. And that's it.